Hello, welcome to 2H TV. In today's class, we are going to use the progressive wave we've proved in our previous class to solve equations. So we are going to look at how we will use the progressive wave equation to solve a given question. And please, if you've not watched our previous video, try and do that. Subscribe, like, share, and comment. So let's look at our first question of the day being projected on the screen. So we read together. It reads that the wave function y bracket open s comma t is equal to 0.030 sine bracket open 2.2x minus 3.5t bracket close is for a harmonic wave on a string. A. In what direction? So these are the four questions we are going to tackle under a wave function which is represented or which is given as y bracket open s comma t should be equal to 0.030 sine bracket open 2.2x minus 3.5t bracket close. So this is the wave function given. Y bracket open s comma t is equal to 0.030 sine bracket open 2.2x minus 3.5t bracket close. Let's look at the general wave equation we proved in our last class. We said that y is equal to a sine bracket open 2 pi ft. So once the wave function given is subtracting, we also subtract 2 pi x over lambda. So in our previous lectures, we established that the general wave equation is represented as this. We also established that omega is equal to 2 pi f and phi is equal to 2 pi x over lambda. Note that a wave constant can be introduced, and a wave constant is represented as k, letter k. So a wave constant is represented as letter k, and it is equal to 2 pi over lambda. So meaning that replacing all these parameters, especially with the omega and the k, into the general equation that we know, then the equation would then look like y now is equal to a sine. Now 2 pi f is the same as what? Omega. So omega t. Then we subtract. Then 2 pi over lambda, which is 2 pi over lambda. We said it's a k, which is wave constant. So k then is left with x. So we get this equation. Now, this equation and this one are the same. So equation given, one can decide to use the first equation and another can decide to use the second equation, and at the end of the day, the answers will be the same, just that the steps will change. So it depends on whichever way you want to go. But in this tutorial, we are going to go by the two methods. Then you see how both methods work. So let's then try to tackle the questions. And the first one is saying question A. So the A side is saying that in what direction does this wave travel? Now, for the direction of travel of waves, if the waves are of the same signs, if the sign between them are the same, then we say that the wave travels from right to left. So if a wave equation is in a state of, let's just have our attention at the Wt minus Ks side. So if it is, the Wt is positive while the Kx is negative, so these are opposite signs. So the wave travels from left to right. So the Wt is positive while the Ks is negative, so the wave will travel from left to right. If it happens that the Wt is positive and the Ks here becomes positive, then we say that the wave travels from right to left. So take note of that. So the first side of question A, which says that we should after you have identified the direction of travel, what is the speed? So we have to find the speed. Now we know that. Now let's use the second equation. So let's assume this is equation 2 and this is equation 1. So we use the equation 2 to solve, then after that we use equation 1 to solve. At the end of the day, we are supposed to get the same answer, just that the methods will change. Now if that should be the case, fast forward, using the equation 2, our velocity, which is the speed, is equal to omega over k. Right, now this is the wave function given and we are comparing it to our equation 2. So meaning that we'll compare the case x side to wherever we can see x in the wave function. So we have 2.2x, and in our general equation we have kx, meaning that the 2.2x and then the ks are related. So we compare 2.2x to what? Kx. So meaning that we have 2.2x is equal to kx. Now we have x, what is in place of the k over here is what? 2.2, meaning that the value for k is equal to 2.2. Get that clear? We are comparing the general equation. We are using the equation 2 for now. So we are comparing the equation 2 to the wave function given. Now we have kx, so we compare to the wave function given where there is x. So we compare kx to 2.2x. So the difference is 2.2. So meaning that our k value is 2.2. Now we compare the second side to, we have omega t. Then in the wave function we have 3.5t. So we compare that, meaning that our 3.5t should be equal to wt. So we have our t, meaning that in place of the omega value now is 3.5. So take note of that. The omega is 3.5 while our k, which is the wave constant, is 2.2. So replacing that into the velocity formula, then we will say that our velocity now is equal to the omega value, which is 3.5, we divided by the k, which is the wave constant, 2.2. So quickly dividing that, we have our we have 3.5 divided by 2.2. So we are getting 1.59. So our velocity is equal to 1.59. And in our previous class, we established that velocity is measured in meter per second. So this is how you go about to find the speed. right? This is how you go about to find the speed if you are using the second equation, comparing the second equation to the wave function given. Now let's look at other way to go about it. Now, before we look at the second method, let's just find the b.